Hello everyone. So finally we are going to solve a numerical of Sarda type fall, which is a question of WRE second unit first. Problem is design a Sarda type fall for following data. Following data are given. Full supply discharge is for upstream and downstream both is 40 meter cube per second. Full supply level is 218.3 for upstream and 216.8 for downstream. Full supply depth is 1.10 for upstream and downstream both, and bed width is 26 for both streams, and bed level is different for both streams, and drop is 1.5. So the question is design the floor on Blick's theory, taking coefficient of creep is equals to 8, safe exit gradient is 1 divided by 5. Then check design by Khosla theory. Okay, now we will start to design. Step number first is height of fall. How it will define? It will indicate by H, and some also values are indicate as full supply depth by D2, and bed width by L, and drop level by HC. So we will also draw a diagram due to its design. If discharge is more than 14 meter cube per second, you can see this is 40 above than 14, then we will design trapezoidal shape of crest wall. So we will use the formula of discharge Q equals to of trapezoidal, which is 1.99 into L to the power S3 divided by 2 into S upon B to the power 1 divided by 6. Then we will understood what is in this. L is the length of crest, or maybe assumed as bed width, which is 26 meter bed width, and we have to find out H. Q is discharge. B, what is B? B is top width 0.55 under root H plus T for the trapezoidal section. Okay, this is trapezoidal crest, this is top width. Okay, so we will find out this. At first we have to find out H plus D. What is H plus D? Then we will write H plus D first. H plus D equals to HC plus D2. This is the formula, and HC is drop and D2 is full supply depth. You can see SC is drop and D2 is full supply depth. So H plus D equals to whether 1.8 plus 1.5, 1.5 plus 1.8, it will 3.33 meter. Then top width B equals to, it will 0.55 under root H plus D, that is 3.33. By the calculation it will approximate 1 meter. So the top width is 1 meter. Okay, now from the equation of discharge, Q equals to 1.99 into L into S power 3 by 2, 1.99 into L into S power 3 by 2 into H upon B to the power 1 divided by 6. Now by putting the values, 40 equals to 1.99 into L is 26 into B can multiply to H by H. It will H to the power 3 by 2 plus 1 divided by 6, and the value of B was 1, that will 1 to the power 1 divided by 6. So by the calculation H will equals to 0.86, which is height of fall. And now we will also find CPA's head hs is equals to d. We know h plus d equals to 3.33. h plus d equals to 3.33. Then what will d? 3.33 minus h. D equals to 3.33 minus h is 0.86. Now d will be 2.4 meter, which is the value of seepage head. Okay, we will also find length of crest above bed. It will d2 minus h. What is d2? d2 is full supply depth, which is 1.8. 1.8 minus h. H have find out 0.86. Now it will 0.94 meter. Okay, the second step is design of crest. Design of crest. For trapezoidal shape, at first we will find out velocity approach. Velocity of approach, APPROACS, which is VA, is ratio of Q and A, discharge and area, Q upon A. What is discharge? Discharge is 40. What is A? A will equals to L plus D2 into D2. Okay, now L is 26 plus D2 is 1.8. All the values is given, and this is also 1.8. Then BA will be 0.8 by the calculation. Now for the part A of step second, which is velocity head. Velocity head VA square upon 2G. What is BA? BA is 0.8. Square upon 2 into G is 9.81. Okay, then by the calculation it will 0.64 divided by 19.62. It will 0.032 meter. The second step B part, upstream TEL. What is TEL? Total energy line, which will find out by upstream FSL plus velocity head. Velocity head. What is upstream FSL? Full supply level of upstream, and velocity found here. Okay, now we will add both. Upstream FSL is 218.3. 218.3 upstream FSL. Okay, plus what is velocity head? 0.032. 218.332 meter. And the third part C of step number second, RL of crest, which is upstream FSL minus height of crest, height of fall, which is capital H. It was 0.86. Okay, then upstream FSL is 218.3 used before, and height of fall was 0.86, and now this will 217.44 meter. Now the last part of second step is value of energy. Value of energy, capital E, which is the difference of upstream TEL, total energy line, minus RL of crest. The difference of both is value of energy, so it will 218.332 minus 217.44. Okay, it is 0.892 meter. So we will find out step Third, which is design of cistern? Okay, design of cistern. To find out this, at first we will find out depth of cistern. For the depth of cistern, there is a formula x equals to 1 divided by 4 E into HC to the power 2 divided by 3. And by this, we will calculate x 1 divided by 4 E into HC. What is E? E is value of energy and SC is drop height. Okay, so value of energy was found at 0.892 and HC was 1.5 drop level given in the question. Okay, now by this calculation we will get the value of x, which will 0.304 meter. This is depth of cistern. And now B part of third step is length of cistern. Length of cistern, which will indicate by LC, is equals to 5 bracket within E into HC to the power half. Okay, by putting values according to previous, 0.892 into 1.5 power half. Okay, it will 5.78 meter by the calculation. Keep length 6 meter, which is approximate value of this. Okay, now we will find out step number 4, which is design of impervious floor. Design of impervious floor. In the last, I will show a diagram which will define that what is the crest, what is the cistern, what is the impervious floor. So for the design of impervious floor, the A part is length of impervious floor. Length of impervious floor will be indicated by LF. Length of impervious floor is C into HS. What is C? C is creep coefficient, which is given in question, and HS is seepage head. What was C? C was coefficient of creep was 8. And what was seepage head? Seepage head was 2.4. And by the calculation it will 19.5 meter. And the B part of this vertical length of creep, which is LV equals to 2 into D1 plus D2. Okay, now we should also understand what is D1 and D2. D1 is upstream cutoff. D1 equals to upstream cutoff, and D2 equals to downstream cutoff. What is cutoff? Cutoff is like that. This is D1 and this is D2. Okay, now what is the value of D1 and D2? There is not given in the question, so we will assume D1 and D2. D1 will be assume 1 and D2 will be assume 1.6. You can assume by yourself. Then LV equals to 2 into D1 plus D2, 1 plus 1 divided by 6. That will 2.6 into 2, 5.2 meter. Okay, now part C of this step, which is length of horizontal impervious floor. Horizontal impervious floor, that will the difference of above two steps, that LF minus LV. What is LF? LF was length of impervious floor, and what is LV? It's vertical length of creep. So by the difference of these two, 19.5 minus 5.2 will be 14.3 meter. Okay, Then find out D part of this step, which is minimum length of impervious floor of downstream crest wall. So this is LD1 equals to 2 D2 plus 1.2 plus HC. Okay, now we will put all the values. D2 was 1.8 plus 1.2 plus HC is 1.5. By this calculation it will 7.5 meter. So we will keep value of LD1 8 meter. Okay, so now step number 5 is checking the floor thickness. Checking the floor thickness by Khosla theory. So in this step, part of A of step number 5th is exit gradient. So exit gradient GE equals to 1 divided by pi under root lambda into seepage head upon downstream cutoff. In the question there is given G equals to 1 divided by 5. So it will 1 divided by 5 equals to 1 upon pi under root lambda into 2.4 divided by 1.6, which will give value of lambda is 5.891. Now we know lambda equals to 1 plus under root 1 plus alpha square divided by 2 is discussed in the design steps in previous video. Okay, so we will put all the values. 5.891 is equals to 1 plus under root 1 plus alpha square divided by 2. Then we will find out alpha from here. Under root 2 into 5.891 minus 1 to the power 2 minus 1, then alpha will be 10.73. Now we will calculate L and B. What is L and B? Is alpha into D2. Now alpha will be 10.73 into downstream cutoff is 1.6. Okay, now it's will 17.17, that L equals to B. Okay, now the B part of this is length of downstream floor which is LD2 equals to 2D plus 1.2 plus HC. What is D here? D was seepage head. D seepage head. HS equal to D. Okay, now put all the values to find out LD2. Okay, LD2 equals to 2. D was 2.44 plus 1.2 plus SC is 1.5 given in the question. So LD2 will be 8.78 meter. Okay, then C part of this design step, length of upstream floor. Then upstream floor we will find out LU equals to L minus LD2. What was L? L or B minus LD2, both may be. Okay, L was 17.17 and LD2 is 8.78. In the above you can see it will 8.39. Okay, this is LU. Now we will also understand the diagram of this. This is a crest I am showing here. This shape is trapezoidal and this is cistern which is also fall of the water, and this is impervious floor, and this is downstream cutoff, which be assumed D2. This is upstream cutoff, this was T1, and we will also draw a diagram like this. You can make the diagram by this, like this, in the exam. Length of, you have to show all the things: length of cistern, depth of cistern, thickness of impervious floor, downstream bed, what is downstream bed, what is upstream bed, as the fall will water of fall will like this is upstream bed, sorry, downstream bed, this is upstream bed, and what was seepage head will be like this, and another ones which will start from here, and it will seepage head. Okay, and everything is evaluated here. So you may assume, you may write here, this is crest, this is cistern, this is impervious floor, and you have to assume all the data, have to find out in design. Okay, thank you.